Okay, so this could be called the anatomy of a black hole. Black holes are kind of weird because I kind of talked about just like that everything's kind of condensed into one little point, one little. But I've also heard it described kind of like he said, and it's like there still is an object, there still is a pit, but even more important than that object is a space we call the event horizon. So if this is the black hole, whether it's a singularity or whether it's this, or sometimes singularities actually are kind of a line, okay? There is a region called the event horizon. And the thing about the singularity, or the black hole itself, and the event horizon, is the event horizon is the point of no return, basically. That's to say that if you are on the inside of the event horizon, you cannot escape the gravitation of the black hole, even going the speed of light. Okay, you're screwed. So you're just going to fall. But if you're on the other side of the event horizon, you still have options. Okay, that's kind of how that works. The radius, or the Schwarzschild radius, is the distance between the black hole out to the event horizon. Okay, so it's a radius. So, there goes Lansing again. So, you kind of see the neutron star underneath the black hole. And remember, if the thing after the supernova type 2 now, the massive star blows up, if after that supernova, the little pit that's left, if it's 3 solar masses or greater, and I think the guy on the video said 3 or 4 solar masses, black hole. So it's going to collapse in on itself, and neutron degeneracy is not going to stop the collapse, and you're going to end up with this kind of crazy sort of thing over here called a black hole. But this is not the only way you get a black hole. There are at least 3, if not 4, ways to get a black hole, okay? And yet in this unit of material, when we talk about galaxies, almost all galaxies have a black hole in their center. And I'm telling you, the black hole in the center of a galaxy is a lot bigger than the black hole that's created after a star goes type 2 supernova. But it's the same idea. All right. So if I were to animate this, I think you guys are fine with this, but if I were to pull this up and animate it, it basically says if that green dot is the black hole. Black holes are not green as far as I know. Okay, but if that's the black hole, and the dot, dot, dot is the event horizon, as you increase the mass that's in that black hole, okay, then the event horizon, that the circle gets bigger and bigger. Okay, so the event horizon gets larger, and of course the Schwarzschild radius would get larger. Okay. Let me go back. Seems like there was a video there. I'll go back too, I guess. Let's see what this is. I liked some of the videos I